I am Dr. Atma Selvi, Assistant Professor in the Department of Food Process Engineering at SRM University, Chennai. Dear students, in this lecture, I will discuss about the principle of concentration and concentration of liquid food by evaporation. Concentration of liquid food is an important unit operation in food industry. Examples of concentrated food products used in day-to-day life are concentrated milk, concentrated fruit juices, tomato paste, etc. And these products can be used as such or reconstituted before use. Food substances basically consist of more water than is required. For example, fruit pulp contains more than 90% of water, and it is difficult to preserve the fruit pulp as such. Concentration is a preservation technique in which part of the water is removed from the liquid substance. As the water is removed, the moisture content of the product becomes less, and these products become self-stable. The objective of this lecture is that at the end of this lecture, you will be able to understand the process of concentration, to know the methods of concentration, to interpret the changes during concentration. Now, let us discuss the benefits of liquid food concentration. As water is removed during concentration, there is reduction in weight and volume of liquid food substance. This in turn reduces the packaging, transportation, handling and storage cost. Next, the concentrated product has less water activity, and this enhances the stability of the food product as the microorganisms will not be able to grow at low water activity. Finally, the concentrated products are easy to reconstitute. The choice of particular method to concentrate depends on the composition of the product, sensitivity of the product to decompose with heat, capacity required, degree of concentration required, whether you need a vapor recovery system, ease of cleaning. Finally, it also depends on what is the capital and operating cost one can invest. The most common method of concentration are evaporation, freeze concentration, membrane separation, ultrafiltration, microfiltration, reverse osmosis, forward osmosis, membrane distillation, vacuum membrane distillation. Today, I am going to discuss about concentration by evaporation in detail. It is the most convenient way of extending the shelf life of food products, either by removing water or by destroying the enzymes and microorganisms which are responsible for food spoilage. The main advantages of heat processing are: this process produces self-stable product without refrigeration. Nowadays, you get milk which could be stored for a year without refrigeration. Heat helps to destroy anti-nutritional factor. Anti-nutritional factor in certain legumes are destroyed upon cooking. Heat processing also improves the availability of some nutrients. Example, enhanced digestibility of protein, starch, and release of bound niacin. Easy to control the processing conditions. As we've seen the advantages of heat processing system, now let us move to concentration of liquid food by evaporation. Evaporation is the most common method used to concentrate the liquid food substances. During evaporation process, heat is applied to the food substance and the water is removed from the food substance as vapor. This process could be done in a vacuum chamber or even without a vacuum chamber. We need to know few terminology involved in evaporation process. for the better understanding of the evaporation process. Due to the transfer of sensible heat from the steam to the food, the temperature of the food substance increases and reaches boiling point. Then, the latent heat of vaporization is supplied to convert the bubbles of water to vapor by the steam. So, the rate of evaporation is ruled by both the rate of heat transfer into the food and the rate of mass transfer of vapor from the food. As we all know, boiling point of water is the temperature at which the water boils at a given pressure. Boiling point elevation of a liquid is defined as the increase in boiling point over that of pure water at a given pressure. During evaporation, water is removed due to the supply of heat. This increases the concentration of the liquid foods. This in turn increases the boiling point of the remaining liquid. As we have understood the theory of evaporation, now let us discuss about the function of an evaporator. The evaporator has two major functions. First is to exchange heat to the liquid substance, and next is to separate the vapor from the liquid. Let us see the components of basic evaporator. The evaporator consists of the following principal unit. First component is heat exchanger, which transfers heat from steam to the food, which is also called as calandria. The second component is evaporating section, where the liquid boils and evaporates. And the last component is separator. Separator separates the vapor from the liquid. Vapor leaves the liquid and passes off the condenser. Now, let us move on to the factors that affects the rate of heat transfer. First, the temperature difference between the steam and boiling point. Higher the temperature difference between the steam and the boiling point, higher is the rate of heat transfer. And this could be achieved by increasing the pressure and temperature of the steam, or by reducing the temperature of the boiling liquid by evaporating under vacuum. The next factor is deposits of fouling on heat transfer surfaces. Fouling is the formation of deposits on the heat transfer surface, which reduces heat transfer and evaporation rate. That is, the efficiency of an evaporator, and also damage the quality of the concentrated product. Then the next factor is boundary film. A film of stationary liquid at the evaporator wall is often the main resistance to heat transfer. The thickness of the boundary film is reduced by promoting convection current within the food or by mechanically induced turbulence. Now, let us learn the various types of evaporator available to concentrate liquid foods. Solar concentration. This is one of the simplest and oldest method of evaporating water from any food substance. The process of making fruit syrup using sunlight is solar concentration. The syrupy pulp from fruits is placed in a pan and cheesecloth is immersed into the liquid, and the cloth is hung above the pan. As the sunlight strikes the wet cloth, the water from the liquid evaporates while the concentrated syrupy pulp remains in the moist cheesecloth. Next, open pan evaporator. This is the simplest and oldest type of evaporators used in food industry. Open pan evaporator consists of hemispherical pan which is heated directly using gas or electric heater or steam. The pan may be kept open or connected to a vacuum pump. As I already discussed, vacuum helps in boiling the liquid at a temperature lower than the boiling point at atmospheric pressure. A stirrer is used to stir the content, and this also helps in preventing food from burning onto the pan. Open pan evaporator is easy to construct and has low capital and maintenance cost and as flexible for application. However, this system has low heat transfer area and hence the residence time of the product in the pan is high. Heat sensitive food materials get damaged due to high residence time. The efficiency of the system is also low. Open pan evaporator is widely used in the manufacture of jam, jellies, fruit preserves, etc. Evaporators are broadly classified based on circulation as natural circulation evaporator and forced circulation evaporator. Now, let us see few examples of natural circulation evaporator. Short tube evaporator. This evaporator is popularly used in pasteurization and sterilization of liquid foods. Short tube evaporator consists of bundles of short vertical tubes of 1 to 2 meter long and 50 to 100 millimeter in diameter. And the bundles of tubes are placed inside the steam chest, which is also called as calandria. High pressure steam is applied around the calandria to heat the product inside the tube. Evaporation of the liquid takes place inside the tubes. The product, when heated, races through the tubes by natural circulation while steam condenses outside the tubes. The liquid is circulated through the downcomer until the required concentration is reached and the concentrate is collected at the bottom. Downcomer is a broad area in the center of the calandria, which is designed for the natural circulation of the liquid. These evaporators have low construction and maintenance cost, high flexibility and high rate of heat transfer when compared to open pan evaporator. This evaporator is highly suited for low viscous liquids than high viscous liquid. Next is long tube evaporators. As the name indicates, this evaporator consists of bundles of long tubes of 3 to 15 meter height and 5 centimeter diameter. Liquid is preheated to boiling point. It is sent to the evaporator. Further heating of the liquid happens inside the tubes and the concentration of the product commences. Expansion of steam pushes thin film of concentrating liquid up the walls of each tube. The concentrated is separated from the evaporator after the removal of vapor. Racing film evaporator. This evaporator is recommended for low viscosity foods like milk. Thin film of liquid is forced up into the evaporator tubes, and this arrangement is known as racing film or climbing film evaporator. Falling film evaporator. This evaporator is recommended for high viscous foods or also for those that are very sensitive to heat. The feed is introduced at the top of the tube bundle and the liquid moves downward under gravity inside the tube. Uniform distribution of the liquid is very difficult when compared to racing film evaporator. Sometimes spray nozzle is used for uniform distribution of the liquid inside the tube. This evaporator is used for heat sensitive food products like orange juice. The total residence time of the liquid inside the evaporator is very short, that is 20 to 30 seconds when compared to 3 to 4 minutes in racing film evaporator. Next is forced circulation evaporator. In forced circulation evaporator, the liquid food inside the evaporator is circulated at high rate using pump. The pump moves the liquid in thin layer and thus maintains high heat transfer and short residence time. The capacity and operating cost of this equipment is high. Plate evaporators. The construction of plate evaporator is similar to heat exchanger that is used in pasteurization and ultra high temperature sterilization. Liquid foods are pumped into the system either by climbing film or falling film principle depending upon the production rate and degree of concentration required. Liquid food is heated by a flow of steam as it rises or falls through the corrugated plate. Next is agitated thin film evaporator. This evaporator is recommended for very viscous liquid foods and those that tends to form foam or foul on the evaporator surfaces. Rotor blades are used for the uniform distribution of feed inside the tube. This system has high rate of heat transfer as the liquid is rapidly agitated by rotor blades and prevent the product from burning onto the hot surfaces. It is used for finishing highly viscous product after concentrating in other evaporator due to its high operating cost. Vacuum evaporator. This evaporator is recommended for heat sensitive liquid foods. As we all know, as the pressure increases, the boiling point also increases. As the name indicates, in vacuum evaporator, a liquid boils in a vacuum chamber due to which the boiling point of the liquid is reduced. Vacuum is created either using mechanical or steam jet ejector vacuum pumps. Next, the important evaporator is multiple effect evaporator. In single effect evaporator, the vapors produced or discarded without any further utilization. In multiple effect evaporator, the vapor produced in first effect is used as the heating medium to boil the liquid in the subsequent effect. This could be achieved by lowering the boiling point of the liquid in subsequent effect or by reducing the pressure in the subsequent effect. Most of the food industry uses multiple effect evaporator to save energy. There are two ways by which you can feed the liquid in multiple effect evaporator. They are forward feed system or backward feed system. In forward feed system, the partially concentrated product leaving the first effect is introduced as feed in the second effect. After additional concentration, product from the second effect becomes feed for the third effect. This system of moving the feed along the direction of steam is called as forward feed system. In this system, the feed will flow without pumping. In backward feeding system, feed moves in the reverse direction. moving from the last effect to first effect. But in the system of feeding, the liquid need to be pumped from one effect to the other due to the increase in the pressure in the subsequent effect. The rate of heat transfer is high as the high concentrated liquid comes in contact with the fresh steam. We have seen various types of evaporator. We have also understood the advantage and disadvantage of each type of an evaporator. So, the choice of particular type of an evaporator depends on the capacity of the system, amount or degree of concentration required, composition of the product, nature of the product, that is heat sensitivity of the product, requirement of vapor recovery system, ease of cleaning, simplicity of operation, capital and operating cost. Now, let us discuss the challenges involved in evaporation of liquid foods. As evaporation proceeds, the remaining liquid becomes more concentrated, and due to which the boiling point of the solution increases. Rate of heat transfer decreases as the boiling point of the liquid increases upon concentration. As the available temperature drop between the product and the steam decreases. As the concentration increases, the viscosity of the product also increases, affecting the circulation. Fouling of heat exchange surface can seriously reduce the rate of heat transfer. Frequent cleaning of heat exchange surfaces requires shutdown of equipment, thus decreasing the processing capacity. Some materials, example, liquid food containing protein. Some materials, especially liquid foods containing protein, may foam during agitation and vaporization, which may cause entrainment of liquid into the vapor phase. The biochemical change that occurs during the concentration of liquid food or oxidation, which causes oxidative rancidity, loss of color, Maillard reaction, which causes discoloration or browning, change in texture, enzymatic changes within the product and changes in flavor. Then the nutritive loss during evaporation. Heat sensitive vitamin C is lost during evaporation. Apart from the loss of vitamin C, other vitamins such as thiamine, vitamin B6 and vitamin B12 also get degraded except for vitamin A, D and niacin. Essential fatty acids and vitamins A, D, E and K or oil soluble nutrients are mostly present within the dry matter of the food. Then the biochemical changes during evaporation. Due to heating, the active compounds present in the liquid food tends to get degraded as they are thermolayable, such as phenolic compounds. Then there will be flavor change during evaporation. Evaporation not only vaporizes water but also cause loss of volatile compounds from the food, and because of this most of the concentrated liquid foods have lesser flavor than the original material. Microbial stability of evaporated foods. Due to evaporation of liquid foods, the pH gets reduced and acidity gets increased along with the increase in the total soluble solids. Since the water content present in the liquid food is removed, resulting in concentrating the liquid food, and this prevents the pathogen from spoiling the food. Let me summarize what I have discussed today. The concentration of liquid food is done by removal of water content from the initial liquid food that which gets condensed to give a concentrated final product with lesser water activity. As the liquid food is concentrated, it helps improve the product stability for a longer period of time, which can be stored in room temperature without refrigeration. The process of evaporation involved in concentrating the liquid consists of removal of water to reduce the weight and volume of the final product and helps in ease of transportation, reduce storage and packaging cost. Concentrating the liquid food is the most convenient way of extending the shelf life of foods by removing water or by destroying enzymes and microorganisms responsible for food spoilage. Removal of water helps in increasing the solid content, reduces the water activity and enhances the shelf life of the food product, and the concentrated liquid food has very good rehydrating capacity. The rate of evaporation is governed by both the rate of heat transfer into the food and the rate of mass transfer of vapor from the food. The evaporator has two major functions: to exchange heat to the liquid substance and to separate the vapor from the liquid. Boiling point elevation of a solution is defined as the increase in boiling point over that of pure water at a given pressure. Evaporator basically consists of heat exchanger, evaporating section and separator. Temperature difference between the steam and the boiling liquid, deposit on the heat transfer surfaces, boundary films at the wall of the evaporator are the factor that influences the rate of evaporation. In solar concentration, solar energy is used to evaporate the liquid food.